you guys again. In this video, we will discuss the remaining part. In the previous lecture, we discussed NFA with epsilon moves and without epsilon moves also. Right? So in this, we will practice them. NFA DFA transition, NFA without epsilon moves to DFA, then NFA with epsilon moves without epsilon moves, then NFA without epsilon moves to DFA. So how we will do this? Let's see. NFA to DFA transition, we will see. NFA algorithm is there. NFA without epsilon moves to DFA, alright? Subset construction. So algorithm. Second, 2 to power n states, alright? So NFA, if NFA have n states, then minimum DFA, how many states? At most, it could be 2 to power at most states, alright? At most could be 2 to power n states is there, right? So yes. So next thing is it's a given NFA DFA. Right? The NFA to DFA. So Q sigma Q transition function of NFA and Q node is there. Essentially final state set of final states. So 2 to power Q set of states of DFA. Alright. And but 2 to power Q is set of of states of DFA, not of minimum DFA, all right? Yeah. So we can reduce that. Q naught will be initial state, F dash will be set of finals, all right? So let's say this is the NFA, A, B, A. So there is two states only. Then what will be the states for 2 to power Q? How many subset we can make from A comma B? Right? Q is A comma B. How many subset would be there? There is 5 state, where there is A state and B and AB also. Which are the final states? Which includes these are two final states, so right? These are two final states, initial state. What is this is initial state, right? So states of DFA subset of Q, alright. So let's discuss next that given NFA to DFA would be this and Q. So what would be the NFA? NFA transition table for NFA that let's say how to make transition table for NFA first. Alright. So the states their inputs or A and B. So A on A, where it can go? It can go A, it can go B, right? On B, this is 5 only. So this is also the case, alright? So how can we go for the DFA state, right? So for DFA, what we can do is, let's say DFA transition table, how can we make that A is there is A, alright? So first we will choose the initial state, alright? So don't make this. This is empty. This is not used as practical things. First take this, alright? So A is there. On A, where we can go? A comma B and 5, alright? What what new state now generated? A comma B here, right? This is initial state. So A comma B is generated from here, right? So what from A comma B, where on A where we can go? We can go we can go A comma B, alright? On B where we can go? We can go B only. we can go, what we can say this, we can go B only, alright? So which new state will now become B? B is a new state. So from B on A, where we can go is on B, I think. Yeah, on B. On B also, we can go only B. So what we are doing is, there are three states are generated now. So what we will do is, these are final state because so initial state is A, alright. Then where we can go is A comma B, alright, and we can go where we can go is, this is from A we can go 5, which is a travel state, alright. This is travel state only, and from A we can go on the input A, we can go final, or and this is final state. We can roam around here. After B, we can make it final, and we can roam around here also. So this is how DFA works. So these are minimum DFA. This is it. Min DFA is here, and it's contain 4 states. All right, 2 to the 4. So 2 to the power 2 is there. Right. Right. So in the next thing is what we are doing, transition of DFA, PQ state of DFA, and I. Where it will go is transition of P comma I union transition of Q comma I. Alright. So this is how it works. So transition of DFA of P comma Q, where it will go on I, it will go on the NFA of that P of I, transition of the P of I union. This is how it works here. Right. Right. And this is NFA. This is the DFA. How we done that let's say this is 1, this is A comma B, A 2, alright, this is NFA, alright. So what we are doing is that this is B here, and no, this is not, we are I am not able to do this. So first make the transition table for what? NFA, right? What 1 and 2, right? A and B is this. From 1 on A we can go 1 comma 2 we can go. On B we can go only 1. From 2 where we can go nowhere, there is nowhere to go from here. So in this DFA table, initial state is 1, alright, the final is 2, so DFA would be first we to pick initial state where we can go is 1 comma 2 and 1. That 1 is already picked, 1 comma 2 we picked. Only where we can go 1 comma 2 we can go only, and on P we can go, on 1, alright, we can go only 1. So these are top, alright. So what the DFA would become that now, first is 1 table, right, and second is 1 comma 2. This is final also. On A where we can will go is from 1 on A is here, B from B is here, alright, but from 2 on A we will come only here, but on B we will go there, alright. So this is how it works, right. I hope you understand this. So let's uh, take the number of states in equivalent minimum DFA is equal to 1. So This is how we done. Because there is no final here. Let a comma b and a comma b is again a comma b. Equivalent DFA will be L is 5 here. So 5 would be an equivalent DFA is a comma b only. Right? This is how this, because there is no accepted thing. So this is implication. Right. So in this case, a comma b a. This is an NFA here. We will number of states and minimum DFA will be what? How they can answer directly from here? I don't know, bro. 1, 2, 3. I don't know. But minimum AB. Minimum is AB. So what is minimum? AB plus 1. 2 plus 1. Yeah, they done. Here was, we can submit also this. 2 plus 1, 3. Western is AB. So minimum is 2 plus 1. East it. So this is how it will go. So NFA to minimum DFA. If any states present in NFA, right? NFA and states, right? Then minimum DFA would contain greater than 1, right? Number of states and main DFA less than of 2 to power n, right? Always important. So this is uh, equivalent to a comma b only, right? Minimum NFA to minimum DFA. If any state present in NFA, then and in minimum NFA, I think. And minimum DFA to the power n, always important. If n states are present in minimum NFA, then number of greater than NFA and number of states and minimum DFA, okay, will be less than 2 to the power n, always important. This minimum DFA is right. So algorithm NFA with epsilon moves to NFA without epsilon moves. So how do we do that? Q is epsilon NFA, Q naught. This would be transition from like this. If you have this. So let's say this is A and this is epsilon here. This is 2 here. This is B. What it is equivalent to? A star, B star. Alright. This is the thing. So first part we will make is without epsilon moves is finalize these two. Alright. This is initial, this is final. Alright. So closure of 1. Closure of 1 would be what? Epsilon closure of 1 would be 1 comma 2, and epsilon closure of 2 is 2 only, right? So without epsilon moves like this. So now what we will do, first we evaluate the epsilon closure of both states, right? So in this, epsilon closure of 1 is equal to 1 comma 2, and epsilon closure of 2 equal to 2 only, right? So what we are doing here is transition of NFA 1 comma I is where NFA 1 comma I where we can go is, so transition of NFA of 1 comma A would be where epsilon closure of transition of epsilon closure of 1 comma a. 1 comma a is the transition. First it is evaluated, then it is evaluated, then we will evaluate the epsilon closure of that. So what we are doing is epsilon closure of delta 1 comma epsilon closure of 1 comma 2, right, comma a. First we will evaluate this 1 comma 2 comma a, where it will go, it will go only for 1 and only, which is 1 comma 2 old cell, which is epsilon closure of cell 1 comma a union 2 comma a, right. Will be epsilon closure of 1 only, it is 1 comma 2, right. This is how this is done, right. So we are showing this in here, that this is how it is done, and 1 comma a is 1, 1 comma b is 5 here, because let's say because 1 is 1 comma 2, from 1 comma 2 where it will go is 1 comma a and 2 comma a, I think 2 comma b here. So 2 comma b is where, 2 comma b is 2 union, it should be 2, no, it should be 2. So 1 comma a is what, 1 comma 2 here, right. So 1 comma a is 1, 1 comma b is 5, 1 comma 2 comma is 5, 2 comma b is 2. So I feel like 1 is 1 comma 2. So 1 comma 2. E comma b. How have they done this? I don't know. Let's see. How is they going to explain this? Now we will discuss 1 comma b. First, epsilon closure of 1 comma b, 1 comma 2, 1 comma 2 comma b. 1 comma 2 comma b should be 2 only. So this 2 is 5, this is 2 only, right? So, right, so 1 comma a, 1 comma b is here. So there is b is 2, right? And 1 comma a is 2 also. 1 comma 2, 1 and 2 here, right? So this is 2 comma is 5. So and 2 comma b is 2 only. So we will decide here, and if you closure first, this is evaluated. This is evaluated firstly. This is second. This is third. Q epsilon I epsilon closure. So epsilon closure of I, then transition of I, and epsilon closure of, this is the process. And uh, what we are doing here is here pass epsilon. यस तुम NFA so NFA and A 1,2 1 comma is X 1 comma is Y also 1 comma is Z also. So what we are doing is given an epsilon and first path and epsilon closure of this 1 comma epsilon. So 1 comma is states then addition of A comma B to A closure of 1 comma X comma Y states partners suggestions. Yeah. Initial of NFA is same as initial of epsilon NFA. Right? Yeah. Initial NFA is initial of epsilon NFA. If epsilon closure is Q, contains final of NFA, then make a Q as a final and NFA. So if NFA Q is closure of like this. Initial of NFA is same as initial of epsilon NFA. Like if closure of Q state contains the final of epsilon NFA, then make a Q as final and NFA also. Right. So Q is this. NFA fail. NFA with epsilon moves to DFA. Epsilon NFA Q not F to DFA to W states epsilon DFA. So what we will do first is alright. So 1 comma one 5 and 5. So only this is how closures works and the closure one is 2. So initial is 1 comma 2. Yeah. So I'll go NFA with FNA moves to DFA. What we will do is here that DFA 1 comma 2 comma A actually closure of NFA comma 2 comma A. So 1 union comma 5. So the 1 is 1 comma 2. 1 comma 2 is here and 2 is here. V 2 V 1. And if I with epsilon moves into DFA. 2, B. So it is basically epsilon equivalent is a short of epsilon and if you right. So if you use epsilon equivalent subset contains file of epsilon liquid. Not NFA with epsilon also. Once normal precision switch using state elimination or expression द्वारा induction में this finite automated regular expression. This is the case. Always C star only. So B star B we do. And this is how we do. A star, B star, B star. This is the language of this. Right? And if we are removing this from here, 1, A, 2, B. A, B star. Alright, we will do this because A is the minimum, so we first do that. And we will do this with that. This is also the case. How we done. And if more finals, make one file using epsilon transition. Right? So these are more finals in here. So A and B. So if it is epsilon 4, 1 over A star A star or B star, that means A plus or B plus. Right? This is how we do it. So more finals, more one final using epsilon transition. One final using epsilon transition. More finals are there. Right? Regular expression. Separate initial if and final. Initial and final. Initial and 1, 3, 2 u. 1 from 1 u to epsilon. Separate piece. 1 b v. First bracket case. What it would be looking a v star v is 1 a b star b here to epsilon here 3. So a b star b star. Next one to find out what now is a b here. B. So this is going to be this epsilon. Right. We have one. Organized star. We got a star. R is here. Beta. So first epsilon. R. 2. Beta. 2 to 5. So R plus is here. So this is also here. So how we will do this? How we will do this is that standards A or B is here, R1 or R. This is epsilon. So epsilon A, we get A, then we will write here. So B, star will repeat this. R will follow. Right. So direct minimum DFA. Right. AB star that AB star is here, epsilon or means this is E, B star is A epsilon, V star is here, B star is there, A 0. Thank you so much. We will meet in the next video. So